It's just math, y'all. Welcome. We're going to graph some more functions. Let's jump right in. So, we were looking at graphing in this radical function and this absolute value function. Now, first thing we want to do on this radical function is determine our domain, so we'll know what numbers to plug in. When we did the previous problems, the domain was negative infinity to positive infinity, so I could plug in anything. But this one's a radical. I have issues with domain. You'll remember from when we talked about domain from an equation. Go watch that video again. From the domain of an equation, we take what's inside the radical and we set it greater than or equal to 0 and solve. So when I do that, I'm going to add 3 to both sides. And x has got to be greater than or equal to 3. That's my domain. X has got to be greater than or equal to 3. So when I start plugging in, I'm going to plug in 3, 4, 5, and maybe even 6. I could do more if I wanted to, but that's what we're going to do. Okay? And so my domain would be all numbers that are greater than or equal to 3, so that would be from 3 to positive infinity. Okay, so that's how we're going to do that. All right, so when I plug in each one of these numbers, I'm going to do the square root of 3 minus 3, square root of 4 minus 3, square root of 5 minus 3, square root of 6 minus 3, and the square root of 7 minus 3. Okay? And 3 minus 3 is 0. The square root of 0 is 0. Okay? 4 minus 3 is 1, so the square root of 1 is 1. 5 minus 3 is 2, and the square root of 2 is, calculator, 1.4. The square root of 6 minus 3 is 3. Calculator, 1.7. And then 7 minus 3 is the square root of 4. Calculator tells me that's 2. Okay, so now these are my points, 3, 0, 3, 0. There's 3, 0. 4, 1. 5. Here's 5, and I go 1.4. 6 and 1.7. And 7 is 2. Okay, so now does this look like what it's supposed to look like? I think it does. Let's go back and look. Yes, it is an arm. It's got a start point, and then it kind of curves on around. And so that is exactly what we have in this particular graph. All right, so we have a start point, and it curves on around. And so that is the graph of this one. All right. Now, let's look at the absolute value. The domain, again, for absolute value is negative infinity to positive infinity, which means I can do any number I want to. So I'll just do my traditional -2, -1, 1, 2. And then I'm going to plug these into absolute value. Now, some people may not know what absolute value means. It's these bars, these vertical bars here. That's the absolute value symbol. And the absolute value is the distance away from 0. It is a positive number. No matter what is inside the bars, once you do the bars, you get a positive number. So let's look at this. Oops, didn't want to do that. That kind of moved everything, didn't it? There we go. Let's get it back. All right, so I'm going to plug in -2 minus 1 in the bars, then subtract 3. -1 minus 1 in the bars, and then subtract 3. A 0 minus 1 in the bars, then subtract 3. 1 minus 1 in the bars, then subtract 3. And 2 minus 1 in the bars, and then subtract 3. Okay, so let's do this carefully. I'm going to slow down because I know I've been going really, really fast. -2 minus 1 negative 2 minus 1, absolute value, then minus 3. Okay, negative 2 minus 1 is negative 3. The absolute value of negative 3, remember the absolute value makes the negative disappear. Go away. There we go. Disappear. Is 3. And 3 minus 3 is going to give me 0. So this one is 0. All right. The next one is negative 1 minus 1 inside the bars, then subtract 3. That's a negative 2 inside the bars, and then subtract 3, and that's going to be a 2. Subtract 3, which is negative 1. So that's negative 1. Okay, I'm running out. I'm going to erase this because this is getting into my space. All right, then I'll do the third one, which is 0 minus 1 in the bars, which is negative 1, which becomes a 1, and then subtract 3. So I get negative 2. And then I think I can do the rest of them without writing it down. I have 1 minus 1 in the bars, which is 0. Well, the absolute value of 0 is 0, and 0 minus 3 is minus 3. And then 2 minus 1 in the bars is 1, and 1 minus 3 is negative 2. Okay, now I'm going to put negative 2 in here. Now remember, this has to look like a V. Okay, if it doesn't look like a V, then I've got to do more numbers. So let's get going. So negative 2, 0. Negative 2, 0. I don't like that. Let me move that. Let me put that better. It's not going to be as straight. Okay, so negative 2, 0. That's my first point. Let's put that on here. Let's pick a good color. Red. Negative 2, 0 is here. Negative 1 is here. 0, negative 2 is here. 1, negative 3 is here. And then 2, negative 2 is here. Do I have a V? I do. I do have a V. I have a line that comes in and then goes this way. And I bet, because if I kept going, I'd go like that. So there's my V. That is my absolute value. Again, the bars here indicate its absolute value, and I should look at the bars and know my graph has to be a V. Just like over here, I saw the radical, the square root, and I know that's a radical, and I know that's got to be an arm looking thingy, and sure enough, there it is. There's my arm thingy. Okay, so now, next video we're going to talk about piecewise functions, graphing piecewise functions. All right, so join us back in just a second.